Hey, it's another year, another milestone, and this is the first and only milestone for Service Pack 1 RAM 751. As a service pack, our main focus is to fix problems. You could monitor which defect is being considered or which one is being worked on from the dashboard on Jazz.net. As you know, we work in the open, so feel free to interact with us through the work items or Jazz forum. Feedback is really what drives us. But beside defects, Service Pack 1 and follow-ons provide some enhancements and affinity of RAM to CLM, or more precisely for an environment of multiple CLM projects. The two driving use cases is for one team to share their deliverables with another, and the other one is for a CLM team sharing their deliverables with the operation teams. I really like to showcase some of these here in M1. Realize though this is M1, so eye squinting is required. The first one is upgrading RAM to support the newly proposed V2 asset OSLC provider. RAM already implements the version 1 OSLC asset provider specification, and you could navigate through the RAM services from the root services URL as you see over here. I'm going to request a star query using the query URL so I could get an atom feed of assets and navigate to one of them. I set my browser to send application RDF plus XML header, which is the reason I will get XML back. This is a V1 OSLC asset in XML form. In milestone 1 you could get the V2 asset if you send the 2.0 in the OSLC core version header. This will give you an RDF XML format which allow RAM to better connect with Jazz applications using the linked data concepts. We are also prototyping for RAM to publish a tracked resource set provider. Word of caution here, as these are only prototypes. Note that version 2 of Asset OSLC is at the finalizing state. The spec may be changing before it is finalized. Give it a try, and again, opening a work item is all it takes to provide feedback. The next thing that I'd like to showcase is the tighter support for the deployment of packages from RAM. As you probably noticed, RAM already supports the OSGI bundle repository protocol. This means that any runtime like WebSphere or a development tool that supports this standard can search and consume OSGI bundle from RAM using OBR. Similarly, in Milestone 1, RAM provides an intimate support for Linux RPMs. If you are using the YAM tools, then you could point to RAM as a YAM repository. RAM will provide two pre-configured types out of the box, a package, RPM package, and RPM capability. One can create an RPM package asset. This will typically be driven by a build process or some type of automation. But notice over here that even though I put dummy information, most of the key attributes, name, versioning, and whatnot will be populated from the RPM package directly. So I'm going to try to upload an install package for a 3D game. And voila, the name, version, and key attributes are driven from the RPM package. At this point, the RPM would be reviewed and go through a regular lifecycle from RAM, and at some point it would get to a state where it could be deployed or used in the deployment process for preparing a node to play a game in this case. As you could see here, RAM will detect the specific capabilities that this RPM provides and as well the linking and dependencies it have on other RPMs. Now that the game is approved for deployment, and if you have YAM installed, you could configure YAM to point to the RAM repository as I'm doing from this directory over here using that repo file. Since I just created this configuration, let me clean and install my game. Now this is Linux's YAM client. No RAM code or extensions here. The next enhancement Milestone 1 started on is the ability to share RAM assets with IWD. IWD provide quick access and deployment of virtual images and patterns. In M1, RAM provides the ability to share script packages across IWD instances. A script package mostly configures a virtual image instance or install a new component on it. So I configured in RAM two connections to two IWD instances, production and QA. I just created a script package asset with a shell script and a CB file. A CB file is an IWD JSON configuration file, and if one exists, RAM will populate its information for you automatically. At the bottom of the asset detail, you could see one of the IWD connections that, according to the asset's lifecycle, one could share the script with. This is done with a new policy in Milestone 1 where you could configure a state in the lifecycle to either allow one to push a script to IWD or not to, or to automatically push those scripts as the asset get to that state. As you noticed over here, only one of the connection was available since we are in the submitted state. Back on the detail page, let me push the script out to the QA instance of IWD. And voila, green colors tell me that this script is married with the QA IWD instance. Remember, this is a milestone, so you see the stickman, the user interface will change before Service Pack 1 is over. As I click on the connection, I'll be transferred to the IWD script package on IWD, and as you could see, the IWD script package has a link back to the library asset. If you have created a script on the IWD instance first, you could use the publish button to push the script into RAM if you're authorized to do so. Back on the script asset in RAM, let me move it to the next state, and I'm going to get the next the production level of connection available. Next, I'd like to show you two cool usability thingies that we have in Milestone 1. First, as you update an asset like this WSDL asset specification over here, RAM will hold its activity also artifact changes. So as you go back to its history, you could revert back later on. The next one, a much asked enhancement, is the ability to specify a regular grammar to validate a text field. Let me just choose a Pursman date validation here. I can give it a try over here in this helper and see if I could enter a valid build ID. Thanks for watching Milestone 1, and come see us on Jazz.net.